end behavior of a polynomial. Mostly it is related to the graphs of polynomials. So there will be 4 cases. So basically the end behavior is affected by 2 things: the degree of a polynomial and the sign of the leading coefficient, whether the leading coefficient is positive or negative. Leading coefficients sign. Okay. So degree, whether the degree is odd or even, that will decide the end behavior. And whether the leading coefficient is positive or negative, that will decide the end behavior. So we have 4 possible permutations. Okay.
Yeah.
Okay. First permutation is if the degree is odd, and the leading coefficient is LC, I'll write it LC, leading coefficient is positive. Next case could be when degree is even, write it here, when degree is even and leading coefficient is still positive. Another case could be when degree is odd and
Then positive.
leading coefficient is negative. We have taken odd and positive case here.
Oh. So then there's even degree, and then there's positive leading, and then negative leading, and then there's odd degree, and then there's positive leading, and odd degree. Okay, negative. Okay, yeah, okay. I think that makes sense. Yeah.
Yeah. So these are the 4 cases that we have. Okay, and we will understand this concept with the help of DESMOS. I will show you the graph of these 4 cases for a 2nd degree polynomial and a 3rd degree polynomial. And we can generalize the results of 2nd degree polynomial to all the even degrees. And we can generalize the results of 3rd degree polynomial to all the odd degrees. So first we'll take the case of even degree and leading coefficient is positive. Can you give me an example of a polynomial with 2nd degree and positive leading coefficient?
5x to the power of 2 plus 3x plus 1.
Okay. Okay, so we have a quadratic polynomial here, and the graph of a quadratic is a parabola. You can see that here. Now we have to study the end behavior of this graph. So end behavior means as we move to the extreme left, so we are at 0, as we move to the extreme left, what is happening to f of x? So we write it as x approaches to negative infinity, what is happening to f of x? And as we move to the extreme right, then what happens to f of x? That means as x approaches to positive infinity, what happens to f of x? Okay, so we have to see the graph of this function. So as you move to the extreme left, the graph, you can see it is, what is happening to the graph? It is also moving in which direction?
Up.
Up. And up is like it just goes all the way up. It has no bounds. Right? So this, if it goes all the way up, that means that it is approaching positive infinity. Okay? And the same thing is happening on the extreme right side as well. Because your graph is like this. So, and these arrows represent that this parabola continues infinitely. Okay, so even if you go to the extreme right direction, just keep going right, then this parabola will keep continuing forever, like forever, literally. Okay, so in this case, whether you move to extreme left or extreme right, your f of x also approaches to positive infinity. Did you understand this?
Yeah.
Yes. So if x is approaching to negative infinity, f of x is approaching to positive infinity. right? If you're going to extreme left. And when x is approaching to positive infinity, that means when you're going to extreme right, the function is approaching to positive infinity. Okay.
Yes.
Now comes the fun part. So we saw that this is what is happening for a quadratic polynomial. Okay. If you take any even degree polynomial, like you take a 4-degree polynomial or 6 or 8 or 10 or 12, just take an even degree polynomial, you will see the same behavior. Isn't that like fascinating? Okay.
I
Now
yield
tell me,
I'm just learning math.
any 4-degree polynomial, there will be same behavior.
4-degree leading.
Leading has to be positive. Leading coefficient should be positive and degree should be 4.
Okay, okay, that's easy then. 7x to the power of 4 plus 4x to the power of 3. 2x to the power of 2. 3x plus 5.
You can also take negative terms.
What I want to do positive.
Yes,
Look
I
how
don't know
beautiful this looks.
Yeah, this blue one doesn't look as beautiful as the red one. Whenever
It looks unique.
yeah, looks like it just makes me so uncomfortable. This is not perfect.
I mean, it's very fascinating, okay? Very fascinating.
Yes. Now, whenever I ask this question, everyone just takes positive terms. And I'm like, why are you not taking negative terms? And in fact, you can even skip a term. Even then it will be.
But I don't want to. I like doing it like that.
Okay, but anyway, the point is the end behavior of the blue graph is still the same, the one that I've written here. Okay. And if you take any even degree polynomial, right, it will have the same graph like this. Obviously, it will have certain changes at the peak. Some graphs would look like this. Some graphs would be like this, but the end behavior will be same. Okay, so that's the end behavior for the first case. For the first case, the graph will look like this, and the end behavior is as x approaches to positive infinity, f of x will approach to positive infinity, and as x approaches to negative infinity, even then f of x will approach to positive infinity. Oh wait, this was for even degree, not for the odd degree. Even degree and positive leading coefficient. Okay, now let's take even degree and negative leading coefficient. Now negative leading coefficient means the first, like the term which has the highest exponent, you make that term negative. So if you make this negative and negative, then what change will happen? Can you guess? Yes, so the graph will simply flip. So whatever you see here,
Yep.
Yes, they will flip like this. Okay, let's do this and make it negative. Whoa, it just flipped. Make this negative, it just flipped. Okay, so now it has been flipped. So now what do you think about the end behavior? As x moves to the extreme left, what is happening to f of x?
F of x is turning.
Like the graph is going down?
Down, but also like, how do I explain? It's kind of.
It is going down and it will keep going down forever.
Infinite.
Yes.
Because you're not equaling to anything.
Yes, and it will never stop. Like it will have no bounds. So as you move in the extreme left direction, f of x will keep going down, down, down So f of x is approaching to negative infinity. When something goes up, okay, infinitely up, that's positive infinity. For y, like, up and down is for y variables and left and right is for x variables. And now this means x is approaching to positive infinity. That means we are going to extreme right side. Even then, f of x is going down infinitely. So, but since it's going down, so negative infinity. Okay.
Yeah.
So this will happen for every even degree polynomial and with negative leading coefficient. So that is the fourth case. So the graph will flip and we should make the arrows. Arrows mean arrows means that the graph is going up or down infinitely. Even you see arrows on a line. That's the difference between a line and a line segment. Line segment is just this much, but a line will have arrows. That means it continues forever from both sides. Okay, so for the fourth case, as x approaches to positive infinity, f of x approaches to negative infinity. And as x approaches to negative infinity, f of x still approaches to negative infinity. Now we come to the odd degree polynomials. Odd. Okay. So, Adviti, can you tell me a polynomial of third degree, so cubic polynomial, with positive leading coefficient?
3x to the power of 3
Mm-hmm.
minus 2x to the power of 2
Mm-hmm.
plus 3 minus 4.
Plus 3x
Wait,
minus...
plus 3x minus 4.
Okay, so see, this is how the graph of a cubic polynomial looks like.
And it looks absolutely wonderful.
Yeah.
It's not a parabola, it's a...
Yeah, it is.
Oh, okay, that's
it does not have a name. It does not have a name. It just is. It just is. It does not have any name like parabola or hyperbola. This graph does not have any name. And if you take any cubic polynomial, like if you skip these terms, see what is happening to the graph.
Repeat that?
Right? This is like this. So you will have either this shape or this shape.
Oh, I've seen that before.
Yeah. Or it will move up and down, or it will become really flat in the middle. Okay. But we are interested in the end behavior. So what is happening this time? As we move to the extreme left. So what is happening to f of x? Like what is happening to
the graph extends opposite directions, so x is approaching positive and it's also approaching negative. So it's going up and down instead of the parabola.
Yes, it is going up and down. So what is happening in both the cases? When you're moving to the left, then what is happening? And when you're moving to the right, then what is happening? I mean, as you change the x values, so what is happening to the y values? That's the question. Look at the graph from this point. This is the graph right now, and it is.
And won't it cause the y values to like move in the opposite directions?
No, where is the graph going? Where is to get idea of the
so
y?
The x it's only going to the y value, not the x. Not
Okay,
really.
See what is happening as I'm going left. What is happening to
The x values are increasing.
What is happening to the values?
Yeah. Isn't it technically decreasing? And the y values is increasing by the negative.
Yes, both are increasing by negative.
Okay.
So when your graph is going down, it is going down, right? As you move to the left, the graph is down, 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 down. Or you can see like this. See now, this is just follow my cursor. What is happening to the y values? They are becoming more and more negative, right?
Yeah.
More and more negative. So as you're moving left and left and left, the y values are becoming more negative. So it is going down. So f of x is approaching to negative infinity.
Okay, now that's interesting.
And what is happening when you go to the extreme right side? Right side, the graph is going up. So you stand at 0, 0 at the origin, at 0, 0, and you start moving in the right direction. So the graph of the function is at 0, 0, it was here, and it is moving up, 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 up. So same thing will happen as you keep moving right. Now the y values are increasing in positive direction. So
Yeah.
as x is approaching to positive infinity, f of x is approaching to positive infinity. Okay.
Yes.
And this end behavior will happen for every odd degree polynomial. That means if you take a 5 degree, 7 degree, 9 degree, 11 degree, I'll copy and paste this and I'll change this 3 to 5. Oh, not much of a difference. See, 99. This is 99 degree polynomial. The end behavior is still the same.
Okay.
Let's check 201.
Oh my god. Dude. 201? That's so specific. It's so random.
Okay, so the point is take any odd degree polynomial and with positive leading coefficient, it will have say this sort of a shape. Like, oh, okay. Okay, so we have the answer for our third case, which is odd and positive leading coefficient. So when x approaches to positive infinity, f of x approaches to positive infinity, and when x approaches to negative infinity, f of x approaches to negative infinity. Okay, and the general shape will be like this. So you just have to remember the general shape, the blue shape. Hello?
Yeah.
Okay.
I'm listening.
Finally, we have odd with negative leading coefficient. So what do you think will happen if I make the first term negative here?
Okay, so if you make all I know is that the right end of the graph will point down, and then the left end would point up. It's like the opposite, they're flipped.
Yeah, the graph will flip. So let's do that. So I'll remove this and I copy and paste this. And
I want to give an example.
what?
I wanted to give an example.
Oh, okay. You can give example. I just wanted to make this small change. See what has happened.
Oh yeah, flip. Oh my god.
It is not
That looks
just
kind of
flip.
crazy.
Yeah, and it is not just flip. Its shape is also different.
Yeah. It's kind of dented. Okay. Okay, then negative 7x to the power of 9
Mm-hmm.
plus 4x to the power of 7
Mm-hmm.
minus 3x to the power of 5 plus 12x to the power of 3 minus 15x plus 20.
We have to set it equal to y. Okay. What in the world is this? Okay.
I like it. It looks absolutely beautiful.
Yeah, I'll just get rid of the red one so that we can see the blue one clearly. See
It's
now,
very nice.
yeah, it is not as nice as the tangents graph. Have you seen the tangent functions graph?
No, I actually haven't.
You should see it right now, then you're gonna love it. Are you ready for this?
Yes. Oh my god, what in the actual heck is that? Get that thing away from me, Miss Vrinda. Nuh-uh. I am not looking at that. This is scarier than proofs. Jesus.
This is why most students don't take trig with algebra, dude. This is
Oh god. Dude, this is not good for me. I'm doomed.
okay. Let's forget about tangent for now. We'll deal with it later.
Oh, my head.
Okay. SOHCAHTOA is only fun till we have to do SOHCAHTOA when it comes to graph
Oh.
and things like this. Oh my god, don't worry about it. We'll deal with it later.
Okay, this is nice.
Yeah, this one is nice. So it's end behavior. Now you tell me what is up with the end behavior as you move left, right. Yes, so when we move to the left direction, what is happening to the graph, to f of x? This,
So when we move to the left,
yes,
what is happening to f of x really?
yes. So you're moving left, 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 left.
Okay,
So-
then if it moves to the left, then the graph would go up. And if
Yes,
it goes to the right, then the graph will go down.
yes. So as x approaches to negative infinity, f of x approaches to positive infinity. And as x approaches to positive infinity, f of x approaches to negative infinity. That's the end behavior. And this will happen for every odd degree polynomial with negative leading coefficient. Okay.
Okay.
So as
Yes.
x approaches to positive infinity, f of x approaches to negative infinity. And as x approaches to negative infinity, f of x approaches to positive infinity. And its general shape will look like this.